Okay, I'm going to try to do this before my evening class starts. My students come. It's going to be a little bit noisy, but anyway, let's go. So, first question says, and remember, the whole idea here is that it's an equation. An equation, you want to keep things balanced. Think of the scale that I mentioned the other day. So that we saw the other day when we started doing this. So the first question, 8 plus 3.8 equals 4.3. So our goal is to isolate the variable, meaning, let me just, over here, so I'm going to make a line. You don't have to, but I like to. This is my left side of my equation, my right side of the equation. My goal is to make that side look like this. Notice that my variable is all alone by itself, and the 3.8 here is gone. So I have to get rid of that. So we talked about inverse operations today. So this is a plus 3.8. So I'm going to do a minus 3.8. I'm going to use the inverse operation to get rid of the 3.8. And then on the other side, I'm going to do the same thing. I'm going to subtract 3.8. If I subtract these two, it equals to 0. So I can just cross it out and pretend they don't exist anymore. So the only thing that's left over is the 8. On the other side, 4.3 minus 3.8. I need to do some borrowing. That becomes a 3. That becomes a 13. 13 minus 8 is 5. And 3 minus 3 is 0. I get 0.5. So A is 0.5. 0.5. So my check, I'm going to substitute. I'll put 0.5 plus 3.8 equals 4.3. And I know that indeed 3.8 plus 0.5 is 4.3. And 4.3 on the left side equals 4.3 on the right side. Okay, so I know I'm okay with that. Right, let me jump here to number 7. Same thing. Our objective, okay, I'm dividing this into left and right side, is to make my variable, that f there, be all by itself. So I need to get rid of this minus 3 over 7. Because it's a minus 3 over 7, I'm going to do the opposite of it, which is plus 3 over 7. Okay, think of opposite cancel each other out. Minus 3 over 7 and plus 3 over 7, when they get together, they just cancel, or they just equals to 0. And over here is plus 3 over 7, because I did that on the other side, so it's plus 3 over 7 here, and likewise here. My f is all that's left over, which is what I wanted. And now I got to add 2/3 and 3/7. I can't add the way it is because my denominators are different, so I'm going to find the LCM, which is 21. How did the 3 becomes 21? Times 7. Times 7 over here is 14. The 7 is times 3, so it's times 3 on top, so it's 9. Now I can add these. 14 over 9, 14, I add my numerators. 14 plus 9 is 23, and my denominator stays the same. Or I can change that to 1 and 2 over 21. 21 goes in 23 one time, 2 left over for 21. So on my check, I'm going to do 1 instead of f. I'm going to replace it with 1 and 2 over 21 minus 3 over 7 equals 2/3. Okay, you would actually have to subtract this to make sure that it equals 2/3. So just because I'm not going to do that, it's going to write 2/3 equals 2/3. So when you do subtract this, it does equal 2/3, which equals 2/3 on the other side. Okay. Let's see what I can do. Let's see 8. 8's a decimal again. Left side. Right? I like this. This is my left side and my right side. My scales that have a left side and a right side. So minus 2.4 equals 0. D minus 2.4 equals 0.2. So it's a minus 2.4. The inverse operation of subtraction is addition. So I'm going to use plus 2.4 here. And I'm going to do plus 2.4 on this side. Plus, okay. Whatever I do to one side, I must do to the other side. The minus 2.4 and the plus 2.4, they eliminate each other, leaving me with exactly what I want, just my variable, which is d. And on this side, I can add 0.2 times 2.4 is just 2.6. Replace it, so I get 2.6, my check, minus 2.4. And you can clearly tell that actually this equals 2.2, which equals 0.2 on that side. Okay. 2, let's see, b. Okay, so again, it's the same procedure. Maybe how you add or subtract might be a tad different, but the idea is the same. We want to isolate the variable. So I want to get this side to look like this. Notice that b is all by itself, and we somehow got rid of the 4.5 here. How do we get rid of plus 4.5? We do the opposite, or the inverse, I'm sorry. It's minus 4.5. And if I do minus 4.5, I'm going to do minus 4.5 on the other side. Okay, so these two become 0. I have b left over. Now I can subtract this. Another way of subtracting this is to change everything into a improper fraction. So let me do that for this example. 3 times 5 is 15, plus 2 is 17. 17 over 3. 2 times 4 is 8, plus 1 is 9, and this is 9 over 2. As you can tell, these are, I changed the mixed number to an improper. I still can't subtract them because they're different. So I'm going to find the LCM, which is 6. That's 6. 3 times 2 is 6, and then times 2 here is 34. 2 times 3 is 6. I'll multiply 3, which is 27. So now I have 34 over 6 minus 27 over 6. My denominator is going to stay the same, and 34 minus 27 is 7. Final answer, 7 over 6, or 1 and 1/6. So my check, in place, okay, so I'm going to write the equation and substitute. Wherever I see b, I'm going to write this value. I'm going to have 1 1/6 plus 4.5 equals 5 2/3. So on the right side is 5 2/3. Let's see this. 1 plus 4 is 5, and 1/6 plus 1.5 does equals to 5 2/3. So I know everything is the same. Let me lower this a little bit more. I don't have time. Do I have to? Okay, I'll do as many as I can before I have to start class. Let's see. One that is, well, let's do 9 because I think it's more complicated. Okay, there we go. Left side, right side. X minus 11 3/5 equals 4 5/8. So I have to make that, I'm going to isolate, make my, on the left side, I have to make that side look like just like X with nothing else around it. So I got to eliminate this minus 11 3/5. So again, the inverse operation, okay, that's going to help me out here is going to be plus 11 3/5, which means I'm going to do plus 11 3/5 on that side. Okay. Minus 11 3/5 and plus 3/5, they will equal to 0. Okay, so these will eliminate themselves and equal to 0. So all I'm left with is x. On the other side, I got to add. So again, well, this one I'm going to just make it a little bit bigger, 4 5/8 and 11 3/5. So you can change this to an improper, okay, and or you can add the fractions first and add the numerator, the whole number separately. So let's do that for this example. So I'm going to cut that in half here. I'm going to add 11 and 4, and that's 15 as far as my whole numbers. My fractions I can't add because they have different denominators. So the LCM is 40. 8 times 5 is 40, so times 5 on top is 25. 11 times 8 is 40, so times 8 is 24. Now I can add because what do you call it? The denominator is the same, so it's 40, and on top I get 49. This I will change to a mixed number, which is 1 and 9/40. So I have two whole numbers, a 15 and a 1, and you know you can't have two whole numbers. So I'm going to combine my whole numbers. My fraction I'm going to leave the same, so my final answer is going to be 16 and 9/40. Okay. I'm not going to do the check because I am running out of time, so I'll try to do as many as I can. Okay. Want me to do this one? 4? Break this into left side and right side. Again, the left side says y minus 3.4. I don't want it to say that. I want it to say just y. So notice that I got rid of the minus 3/4. I just can't throw it away. I have to give you a reason. And to justify how I threw that away, I'm going to do plus 3.4. And if I do plus 3.4 on this side, I will do plus 3.4 on that side. Okay? It's a scale. Whatever you do to one side, you must do it to the other side to keep it balanced. These two will be 0, will amount to 0, and y is going to be left over. And on the other side, 6 plus 4 is 10, goes 1, dot, 8 plus 3 is 7, plus 1 is 8. So that y equals 8. If I substitute, I'll get 8, is that minus 3.4 equals 4.6? Is that true? If I had $8 and something cost me $3.40, will I get $4.16 change? Yes, I would. So I know that 4.6 on this side and 4.6 on that side is correct. 10, 11 should be pretty easy to do. I will do 5 because it's a fraction. Okay. So let's go. So we have, again, don't forget that line. Is it mandatory? We talked about it in class. No, but I think it does help us see that an equation has two sides, left side and the right side. I want this, the left side, to just have C, my variable all by itself. So we need to get rid of the plus 2 and 3/4. And because it's a plus, we're going to do minus, the inverse. And on the other side, I'm going to do minus 2 and 3/4. Remember, whatever you do to one side, you do to the next. Now, a plus 2 3/4 and minus 2 3/4 is going to kill each other and have nothing left. They're going to be 0. So C is the only thing that's left over on that side. On this side, I'm going to subtract 3 1/4 and 2 3/4. So this one, I'm going to do a little thing. I'm going to change this to a decimal because they're both fourths. 3 1/4 is the same thing as 3.25. 2 3/4 is the same thing as saying $2.75, right? I can now subtract much easier. So if you had $3.25 and something cost $2.75, how much would you have left over? In that case, 50 cents. Much easier when you can change the decimals. Okay. That won't happen when you have a 3 as your denominator, but when you have 4 and 5s, you can do that. Or even 10s and 20s. The check, so it's C. I can't read it. C, so you have, what happens when you have C, which is 50 cents, plus $2.75. Does that really equal $3.25? I change everything to decimals. Yes, it is. 50 cents plus 2.75 is 3.25, which equals 3.25 on the other side. Okay, so there's something that you could definitely do. I'll do 12. Okay, 12. Again, left side, right side. We want the variable x to be all by itself, saying x equals something. And let's do that in order. We have to get rid of the minus 4. And we'll do the inverse, which is plus 4. And we'll do plus 4 here. This minus 4 and plus 4 equals 0. X comes down. And 4 plus 7/9 is just 4 and 7/9. That was pretty easy. To check, we're going to go 4 and 7/9 minus 4 equals 7/9. Okay, that one's pretty obvious. So it is 7/9, which equals 7/9 on the other side. Okay, I'm not doing the rest of this sheet. There's probably 2 or 3 that I left out, but I hope, do I have time? Okay, I can do one more. I'll pick, let's do this one. So again, we want B to be by itself. We have to get rid of the plus 1.3, so it's minus 1.3, which means it's minus 1.3 on the other side. These two become 0. B is left over. So try to put the decimal under the decimal, and then I'm going to add 0 here as my placeholder so that both numbers have 2 decimal places. It's a minus, right? So 1 minus 0 is 1. I need to borrow. 12 minus 3 is 9, and 8 minus 1 is 7. So I get 7.91. My check is going to look like 7.91 plus 1.3. Is that really equal 9.21? Yes, it is. 9.21 equals 9.21. Okay, so pretty simple. Actually, we did harder equations when we were doing the scale 2 days ago. Okay, or sorry, yesterday. All right, and that's that.